All right, so today we are working on multiplying and dividing with our complex numbers, which we've already done a little bit, but we're just going to practice that skill a little bit more. So remembering our cycles of I. So we got I to the first. I squared is -1. I to the third is -I. And then I to the fourth is 1. Some people I know prefer to see it as the clock. We got 1, I, -1, -I. So if you prefer it that way, draw your clock. You can draw your clock in every single paper you get when it's dealing with I's. So for today's lesson, we're going to need to know A plus BI and A minus BI. Who remembers what those are called? Conjugates. Good. If we multiply our conjugates, remember, all you have to do, multiply the first ones together. So A times A would give us A squared. And then you multiply the second parts together. So that would get us minus BI squared. And I put parentheses around it because you have to square the B and you square the I. So that's the whole reason we multiply by conjugates, is because you want to get rid of that middle term. So when you do that, you just multiply the first ones, multiply the second ones together. So let's take a look at our examples here. So we're going to express the product of 2i times 3 minus 6i in the form A plus BI. So this is like what we've done before. Just need to be doing some distribution here. So 2i times 3 will give us 6i. Just multiply those numbers in front. I stays there. 2i times -6i will give us -12 because 2 times 6 is 12. And then I times I gives us I squared. And then remember, we always have to clean this up. We can't have an exponent higher than 1 on our i's. So I squared, remember, reduces down to -1. I'm going to bring down my other parts of that also. I still have that minus sign there, and I still have that 6i. So -12 times -1. Just make that turn positive. And we still got that 6i there. But remember, that's not our correct complex number form. We just have to switch this now. 12 has to come first. 6i has to go last. Your I term always goes last. All right, let's try the second one. Same thing. We have some distribution. This time we're just going to distribute it 3 times because we have 3 terms inside of our parentheses there. So -5i times I squared would give us -5i cubed. Remember, you add those exponents. So 1 plus 2 gives us I cubed. -5i times -2i would become positive 10i squared. And then -5i times 1 becomes -5i. So now we just have to do our simplifying. I to the third, if we look at our chart up above, what does that simplify to? -I. So I got my -5 times -I for that first term. So what does that multiply out to be? Positive 5i. Negative times negative just makes that positive. So for our next one, we got the I squared. So that turns into -1. So I got 10 times -1. That makes that -10. And then our -5i, can we reduce that at all? No, that's already as reduced as far as it's going to be. So I'm just going to bring that down. Nothing else can be done to that one. So now let's combine our like terms. And when we do so, what happens to our 5i's? They cancel. Positive 5i minus 5i would be 0. So all that's left there is your -10. Three, express the product of 5 plus 2i and its conjugate in simplest terms. Product means we're going to multiply. So I'm going to start with the one they gave us, 5 plus 2i. Its conjugate would simply be 5 minus 2i. Remember your conjugate, you just change that term in the middle. And now we need to multiply. So we have to just first multiply those first two terms. So 5 times 5 gives us 25. And remember again, the whole reason we multiply by that conjugate is it gets rid of the middle term, so we don't even have to multiply for that. We just then also multiply your last two. So that gives us a negative 4i squared. So then again, I squared turns into negative 1 when we simplify it. We still got that 25 there. Negative 4 times negative 1 becomes a positive 4. So 25 plus 4 gives us a 29. So our final answer is 29. Whenever you multiply those two conjugates, it's always just going to be a number. It's not even going to have an I in it anymore. 4. This time we're taking 2 minus I and we're squaring it. So 2 minus I times 2 minus I. You got to keep in mind these are not conjugates, so it doesn't follow the same rules as we did for the last one. This one you got to actually multiply it all out. So 2 times 2 gives us 4. And then 2 times negative I gives us a negative 2i. Now we have to distribute this negative I. So negative I times 2 gives us another negative 2i. And then negative I times negative I is going to be a positive I squared. So again, I squared is negative 1, so I'm going to replace that with negative 1. So now combining our like terms, 4 plus a negative 1 gives us 3. Plus a negative means we're just really subtracting. Negative 2i minus 2 more i's will give us a negative 4i. Again, not conjugates, so you still have I as part of your answer. It looks like conjugates, and some people get confused, but it's not. All right, let's take a look at the back. So that was multiplying. When dividing or simplifying a problem containing a plus bi, it is necessary to rationalize the denominator if it contains an I. Because again, I is the square root of negative 1. As we learned in our last unit, you can't have radicals in your denominator. So since we can't have radicals, we also can't have i's because I represents a radical. So if I is part of the monomial denominator, multiply the numerator and denominator simply by I. So if it's just one term with an I, you're going to multiply top and bottom by I. If it's part of a binomial, so 2 terms, you're going to multiply top and bottom by its conjugate. Which remember, conjugate just means you change the sign. So if it's a plus bi, you'd multiply it by a minus bi. So let's take a look at our examples. So our first example here, we have negative 15 over 3i squared. Let's clean up our I squared. Again, I squared is negative 1, so this in our denominator really means it's 3 times negative 1. Which 3 times negative 1 will give us negative 3. And so now we can just simply divide. So negative 15 divided by negative 3 gives us 5. So that one, all you had to do is simplify your I, and then you could actually do your division. Number 6 is different though, because your I is already as simplified as it's going to get. It's I to the first power. You can't simplify that anymore. So what we're going to do, it's just one term in the denominator. So all we have to do is multiply top and bottom by I. So up top, I have to multiply the I times both terms that are in my numerator. So I times 3 is 3i. I times I is I squared. In our denominator, we're going to multiply 2I times 1I becomes 2I squared. So now we need to simplify our I squareds. So this one becomes -1. That one becomes -1. So in our numerator, there's nothing we can combine. We got 3I and we got a -1. So all we have to do is we just have to rearrange it so it's in the correct complex number form of A plus BI. So that number has to go first. I has to go last. In the denominator, it's going to be 2 times the -1. So that gives us -2. And then that's our final answer for that one. So if you just have a single term, multiply top and bottom by I. Number 7, our denominator is not a single term. We have 2 terms there. So we have to multiply the top and bottom by the conjugate. Which would be 7 minus 3I. Again, you just change that sign in the middle. So up top, I've got to multiply that 2 by both parts of that conjugate. So 2 times 7 gives me 14. 2 times -3I gives me -6I. So 14 minus 6I. In the bottom, since they are conjugates, remember you just have to multiply those first terms. So 7 times 7 gives us 49. Multiply those second terms together, gives us -9I squared. 3I times -3I is -9I squared. Again, conjugates, that's what you do. Just multiply first, multiply the last. So the only thing we have to clean up is down here in this denominator. This -9 is really times a -1 because I squared simplifies to be -1. So I have 14 minus 6I up top. And it ends up being 49 plus 9 in our denominator. Because that -1 turns that -9 when you multiply positive. So what is 49 plus 9? 58. So now can we reduce those 3 numbers? Is there a number that goes into all 3 of them? 2. So 14 divided by 2 is 7. 6 divided by 2 is 3. 58 divided by 2 is 29. So there's our final answer. Always remember to reduce whenever possible. All right, and then our last one for our notes. What are we going to multiply by? It's 2 terms. So the conjugate, 2 plus I. So now up top we have 2 binomials multiplied. So we have a lot of things to multiply here. So we got to do 8 times 2, which gives us 16. And then the 8 times I gives us 8I. And so now we need to distribute the I. So I times 2 is 2I. I times I is I squared. So we had to distribute out our numerator. Denominator, we're multiplying conjugates. So again, multiplying conjugates, you just do the first 2 multiplied. 2 times 2 gives us 4. Multiply the last 2. And that gives us -I squared. So now cleaning it up, we have 2 I squares we have to reduce. So I squares turn into -1. So for our numerator, we have 16 plus a -1. So that's going to give us 15. And then 8I plus 2I gives us 10I. And then for the denominator, 4 minus -1 really means we're adding, so that becomes 5. So then we can divide here. 15 divided by 5 is 3. 10 divided by 5 gives us 2i. So 3 plus 2i ends up being our final answer for that one. So again, if you just have one term in the denominator, multiply by I. If you have two terms, you got to multiply by that conjugate.